So let's start with example 1. Okay, find the area bounded by the graph fx equal to x plus 1, the x-axis on the interval 0 and 4. Okay, let's see how to do about it. Okay, so solution is, first of all, we divide the interval 0 and 4 into n equal parts. Okay, this is the first step. So we know that the width of one of the parts is delta x, and that is equal to the second b minus a by n. That means the second point minus the first point upon n. So what is the second point b equal to here? The second point here is 4. So we are finding out the area between the points 0 and 4. So this is equal to 4 minus 0 by n, which is 4 by n. Okay, this is number 1. Now we have to find out what is the value of the function at the ith interval, right? So this is equal to finding out the function. What is the ith interval at x? What is the value of x at the ith interval? It is the initial point, that is a, plus delta x into I, right? It is in delta x, that is the value of one interval, or the width of the one interval, into I. This is denoted by f is equal to a plus b minus a by n into I, right? Okay. Okay, so this is now equal to f. What is the value of a? The value of a is 0 plus 4 minus 0 by n, that is 4 by ni. So we have to find out the value of the function at 4 by ni. From the concept of functions, okay, we know that the value of the function at any value of x is, we have to plug in that value into the function itself. So what is the function given here? The function given here is fx equal to x plus 1. So this will serve as an input. This will serve as an input into this function. So what we are going to get is this. Okay, we are going to get, if we input the value of x now, that is 4 by n I, into this function fx, we will be getting 4 by n I plus 1. So the value of the function at the ith interval is 4 by n I plus 1. So we got the value of delta x, we got the value of the function fxi. Now it's just a question of applying the basic Reimann sum formula, which is a equal to summation of I is equal to 1 to n, sorry, I forgot, this is limit as n tends to infinity, because we are defining n intervals where n is extremely huge number of intervals in order for the area to coincide, area to be equal to the area under the curve. Okay, so this is equal to f of xi star into delta x. We just have to plug in the value of this and the value of this, which we have got earlier, to get the sum. So n tends to infinity. F of xi is what? 4 by n I plus 1 into what we get for delta x, that is 4 by n, right? So, and we have to put in the summation symbol here, I is equal to 1 by n. Okay, so let's see this one now. So this is equal to, again, limit as n tends to infinity. Okay, summation I is equal to 1 to n. This is 4 into 4, that is 16. N into n is n squared I, right? Plus 4, this is 4 by n. Okay, 4 by n. This is 4 by n. Okay, fine. Now, we know earlier from the law, from the first 6 rules that we took earlier. So, that means the summation of a function x and a function y will be, we can find out the sum in a separate manner. So, we will split this. So, this is equal to limit as n tends to infinity, summation of I is equal to 1 to n 16 by n squared I, plus again limit as n tends to infinity, summation of I is equal to 1 to n of 4 by n. Okay, now this is a constant, right? This is a constant part. I is the variable part because I is changing, and we already know from this is from rule number 2. Okay, now rule number 4 says summation of I equal to n, I equal to n of I is n into n plus 1 by 2. So let's do it. Okay, so this becomes 16 by n squared into summation of I equal to 1 to n of I, right? And plus 4 by n, this is the summation of the constant. Okay, 4 by n into summation I is equal to 1. We leave this as it is. So since this is a constant, summation of I is equal to 1 to n of 4 by n. Okay. Now we know that this is equal to, now this is 16 by n squared. This is equal to, so we multiply this by summation of I is n into n plus 1 by 2, right? N into n plus 1 by 2. Now this is 4 by n in the constant. We know from the rule that it will be 4n and summation from I equal to 1, n is n. Okay, so this n and this n cancels off. So we are getting now 16n, that means 8, and this will go into, this is 8. So it is 8n by n. So it is 8n, 8 into n plus 1 by 2n. Plus 4. Okay, so 8n by n, sorry, 2 is gone, 8n by n plus 1 plus 4 upon n. So this will become 8n by n plus 8 by n plus 4 by n, right? So, and obviously we are not forgetting the limits now. So we have to write the limit as n tends to infinity of this whole expression. Okay, so this is limit as n tends to infinity of this whole expression. Okay, so this is limit as n tends to infinity of this whole expression. So this finally we get equal to limit of 8n and n cancels here. So it is limit of n as n tends to infinity plus limit as n tends to infinity of 8 by n plus limit as n tends to infinity of 4 by n. We know that as n tends to infinity, this will become 0. This will become 0. So finally we get limit of 8 plus 8, and we have forgotten the 4s. We have forgotten the 4 here, right? So 4 is also there, plus 4 is there. So limit and limit of 4 is 4 remains. Limit of 8 remains. This is plus 0 plus 4, which is 12 square units. So this is how we come to the finding out the area under any curve. Okay, thanks for watching. Okay, next I will be taking another one example on this one, a slightly complicated example on this one, so that things become more clear. Thank you.